The Flohouz, house innovation adapting and protecting from sea level rising at low-lying coastline, designed by Cherise Nene. Objectives: Number 1. Identify and research the problem, how island or low-lying coastline might adapt to or combat rising sea levels or storm surges. Number 2. Planning a solution. Plan and design a structure for low-lying coastline to adapt or protect rising sea level or storm surges. Number 3. Create a model solution. Creating a structure for low-lying coastline to adapt or protect rising sea level or storm surges using recycled materials. Number 4. Test the model. Testing the model for its function and how well it solves the identified problems. Why is the sea level rising? The sea level is rising due to the climate change from global warming, while we make it worse by doing the greenhouse effect activities such as burning fossil fuels, algae culture, and many more. What happens if sea level rising on low-lying coastline? Changing sea level are affecting human activities in coastal areas. Extreme rising sea level on low-lying wetlands and dryland contributes to coastal flooding and increase the flow of salt water into estuaries and nearby groundwater aquifers. Higher sea level also makes coastal infrastructures more vulnerable to damage from storms. This includes damaging the house around the coastline.
The ocean covers more than 70% of the Earth's surface, with nearly half of the world's population living within 100 kilometres or 60 miles of the coast. Many are at risk of the destructive impacts of storm surges. A storm surge is a change in sea level from the usual predicted tidal water levels driven by weather systems. A positive storm surge can occur with low pressure systems and leads to exceptionally high tides, which can lead to extensive flooding in low-lying coastal regions. While small positive surges occur quite frequently, the potentially more damaging events occur with larger scale, more intense low pressure systems. The most well-known of these are tropical cyclones or hurricanes. The main contributing factor are the high winds that push the seawater towards the coast. It is also possible for a negative storm surge to occur, resulting in abnormally low tides. When the wind direction blows the water away from the coast instead, this causes the sea level to be lower than predicted. These are less dangerous as they do not bring the risk of flooding, but they can damage ships in port and leave them stranded until the water level rises again.
Flood control on low-lying coastline. There are two methods of flood control on low-lying coastline. Protection: by making flood barriers such as putting rocks, planting mangroves and seawalls, gabions. Adaptation: by putting barrels or putting stilts under your house to make it float. Here are the examples for protection and adaptation: flood barrier, rock armor, mangrove barrier, seawall, stilts and barrels underneath. Designing the solution. In here you can see the materials we use to create the model. In here we use cardboard and popsicle stick, styrofoam, straw, stick, and art foam. As in for the real life, we will use concrete for the house barrier, concrete for the straw. We will use bamboo stick for the stick, concrete for the art foam. The Flohouz. The Flohouz is a model designed by Cherise Nene. We created to make a solution for houses that are in low-lying coastline that has experienced a flood. The function of this is to make the house float and protect the house from the wave by building barriers. We have two barriers. Seawall. It attached on the house to protect the wave from damaging the house. We choose a specific shape to minimize the impact of the wave. Outside barriers. We build a rock armor outside the house to slow down the wave. Findings on testing. We tested the house by pouring water after some liter. We saw the house started to lift up and finally it floated. We believe that the house could float because of the materials we used. We tested two different shapes for house barrier, flat and curve. We found that the curve was better barrier. As for the flat one, we can see that the water went over it and splashed to the house. In our opinion, the curve is better barriers when the wave comes it and trap it and push it back. So we chose the curve-shaped barrier. After testing the model by putting the rock armor in front of the house, we can see the wave decreasing in height and power. We believe the rock armor break down the wave, then it decreasing its length and power. We could see the wave's movement became slower. How it works. This video will show you on how our model house works. Creating the model. This is our process on creating the model. Our good struggle in this project. We struggled on how to choose for protection and adaptation. At first, we wanted to put a plastic bottle underneath the house model and use rocks to hold down the house. But after some trials, we changed the materials and plan. We struggled using the hot glue gun, especially on how to minimize the amount of glue we put in. We struggled with time management to finish this project, but we catch up with doing it at home on the weekend and weekday after school, trying to place where the sea barriers should be. Summary. We believe the house model will create a solution for the low-lying coastline area that has been destroyed by coastal flood and storm surges. Because the model could protect from coastal flood and storm surges by giving better barrier. As for the rock armor that has been placed outside the house would slow down the power of the wave and reduce its height. In conclusion, the house model not only could protect but also to adapt to coastal flood and storm surges by floating. Thank you. We hope you enjoy.